So here we'll look at the various tests for symmetry. Symmetric about the y-axis. So look at this. Example 1 is an example of a graph that's symmetric about the y-axis. Changing x to negative x does not change the equation. If that is true, then the graph is symmetric about the y-axis. In the second graph, we have a graph that is symmetric across the or about the x-axis. Changing y to negative y does not make a difference in the equation. So if we are given the equation of the graph, if we are given an equation, we plug in y, negative y for y, and if it does not make a difference in the equation, then we can conclude that the graph of the equation is symmetric about the x-axis. Now, how do we check for symmetry about the origin? So here's an example of a graph that's symmetric about the origin. Changing x to negative x and y to negative y does not make a difference in the equation. So that would be an example of a graph that's symmetric about the origin. So this is the graph of y equals 1 over x. This is the graph of y squared equals x. And this is a graph of y equals x squared, the parabola. So let's look at a few examples here. Now, if we didn't know what the graph of the function looks like, so let's start with y equals x to the 4th plus 2x squared plus 1. If we didn't know what the graph looks like and we wanted to check for symmetries, then this would be x is replaced with negative x, right? So replace x with negative x. And when we simplify it, negative x to the 4th power is positive x to the 4th, negative x squared is x the whole squared is positive x squared. So nothing changes. So we can conclude that the graph of this equation is symmetric about the y-axis. Let's take the same equation and change y to negative y. The entire equation changes. So what happens is it becomes y equals, and if we took negative on both sides, it would be negative x to the 4th minus 2x squared minus 1. And it's not symmetric about the, in this case, it is not symmetric about the x-axis. So what we did here was changed y to negative y. And the graph changed, so therefore we can conclude that it is not symmetric about the x-axis. Now let's look at the equation y equals 1 over x. So we replace x with negative x and we get y equals negative 1 over x. So the equation did change and it is not symmetric about the y-axis, because changing x to negative x did make a difference in the equation. Now changing y to negative y again changes the equation, so it is not symmetric about the x-axis. So here we changed x to negative x for checking if the graph of this equation would be symmetric about the y-axis. Here we changed y to negative y to check if the graph of this equation is symmetric about the x-axis. Now, if we change both negative y, y to negative y, x to negative x, we get negative y equals negative 1 over x, multiplying both sides with negative 1. We get back the equation y equals 1 over x. So this tells us that changing x to negative x and y to negative y together did not change the equation, which means that the graph of this equation is symmetric about the origin. Now let's look at the next example, y squared equals x. If we are trying to figure out if this is symmetric about the y-axis, the x-axis, or the origin, we have to do the test. So the first test is changing x to negative x. And here we are testing if it's symmetric about the y-axis. And clearly changing x to negative x does change the equation, which means it is not symmetric about the y-axis. Now we start again with the equation y squared equals x. We change y to negative y. So that's negative y the whole squared equals x. Squaring, we get positive y squared, so nothing changed. The equation remained unchanged, even though we changed y to negative y. And this is a test that tells us that the graph of this equation is symmetric about the x-axis. Now we're looking at that last example here, 1 equals xy. So xy equals 1 is the equation. And we'll check if the graph of the equation, when we graph this equation, will we find that the graph is symmetric about the x-axis, the y-axis, or the origin. So if we change x to negative x, we are testing for symmetry about the y-axis. So this is what we are checking. Is it symmetric about the y-axis? How do we know that? We replace x with negative x. The y remains unchanged, so we're only changing the x. So this gives us negative xy equals 1. So the equation has changed, which tells us that it is not symmetric about the y-axis. Now we can repeat the same process, except that we change y to negative y. The equation does change, so that is x times negative y equals 1, which means negative xy equals 1. The equation has changed, so therefore it is not symmetric about the x-axis. So no symmetry about the x-axis. It's not symmetric about the y-axis. Now we check if it's symmetric about the origin. Change x to negative x and y to negative y. Simplify. So you get xy equals 1. So therefore, this has remained unchanged from here to here. We've changed the x and the y, but the final equation is the same. So it is symmetric about the origin.